Here in this video, we'll see a problem on projection of lines inclined to both the planes. Here is the question. The front view of line AB, 70 mm long, is inclined at 45 degree to XY line, measures 50 mm. The endpoint A is 10 mm above HP and 20 mm in front of VP. Draw the projections of the line AB and find its inclination with HP and VP. So this is the question in front of us. Now, while reading this question, we should see that in the question of projection of lines inclined to both the planes, we should have at least 5 parameters to solve the question. So I'll be reading this question again and writing all the parameters which are given to us. The front view of line AB is 70 mm long. It means the true length of the line is given. Then the front view of line AB 70 mm long is inclined at 45 degree to XY line. So inclination of the front view has been given here. Means this is not the inclination of 70 mm long line, but it is the inclination of the front view. And if I see here, it is given that measures 50 mm. So the front view of the line is measuring 50 mm and that is inclined at 45 degree. So here I'll write down, since the front view is given, front view length, that will be called as elevation length. EL, which is 50 mm. Then it is inclined at 45 degree. So that is alpha is equal to 45 degree. Next, the end point A is 10 mm above HP, 20 mm in front of VP. And 20 mm in front of VP. Draw the projections of the line AB and find its inclination with HP and VP. So we have to draw the projections and find the inclinations. That is, with HP the inclination is theta and with VP the inclination is phi. These two values are also to be found out. Now starting with the solution part to this question. In the solution part, here I'll draw the XY line first. Since the location of point A is given, I'll locate it first. 10 mm above HP will be seen in VP. Here I'll draw a light vertical line. 10 mm above HP, 20 mm in front of VP. That is the location of point A. In the front view it will be A dash. In the top view point A. Next, after marking point A, the true length is given. Elevation length, that is, this is the apparent length which is visible in the front view. Now since these are questions related to lines inclined to both the planes, in that case, if the true length is 70 mm, then in the front view or in the top view, the true length won't be visible, or it means that the length of the line which will be visible to us will be called as the apparent length. So the apparent length in the front view is 50 means 70 mm has become 50 mm and it is inclined at 45 degree. So here I'll measure an angle from A dash at 45 degree, drawing a light line. Alpha is 45 degree. Elevation length is 50 mm. So I'll measure that elevation length. So from A dash, I'm cutting this line and giving the notation as B dash. Now that is the actual length of the line. So I'll directly make it dark because elevation length shows the actual line. Then from point B dash, I'll draw a light line. Locus of point B. Then over this locus, I'll get the true length, which is 70 mm. So measuring that distance, seventy, keeping it on A dash, cutting this locus, then joining it with A dash. Now this point, I'll say it is B1 dash. Next, here this indicates the true length of the line. I'll write it down. That is true length is equal to 70 mm. Then similarly for the top view, I need to get this actual length and true length in the top view. For that, through B dash, I am projecting a light line. Then similarly bringing B1 dash in HP, that is over this horizontal line. Then I'll give the notation here. I'll call this point as B1. Then measuring the distance B1 from A. So here I am measuring the distance from A to B1. So that it is cutting this line which is passing through B dash. It means wherever the apparent length in the front view is there, between that same projectors there should be the apparent length in the top view as well. So here I am getting this point. I'll say it is point B, joining them with the help of light line. Next, this is the apparent length in the top view, so I'm making it dark. Then through point B, projecting a light line. This is also locus of point B. Here in the front view it was locus of B dash, and in the top view locus of point B. Then similarly I'll measure this true length, which was 70 mm, keeping it on A, cutting this locus, or in other words I could have even got it in this way, like drawing an arc here and projecting it down. Now this is the intersection point, joining it. I'll say this is point B2. Then A dash B dash and AB2 should be medium dark. This is elevation length 50, true length 70. This is plan length 50. Now elevation length was having an angle alpha. Similarly, the plan length has an angle beta. Next, the angle of the true length of the line will be called as theta, because this is the inclination of the line, or we can say true length of the line, with HP seen in VP. Next, the inclination of the true length of the line with VP seen in HP. This angle will be called as phi. So I need to measure this angle. So at first I am measuring the angle theta. It is coming out to be 30 degree. So therefore the inclination of the line AB with HP is theta is equal to 30 degree. Answer 1. Next, similarly, the inclination of the line AB with VP is phi is equal to 43 degree. And with this, the problem gets completed.